All right, next concept is diffusion and effusion. So diffusion is just the spread of a material. So molecules spreading out. While effusion is pretty much the same thing, except now they're going through some kind of small hole. So it's the escape of gas through a small hole, right? So either way, we're talking about gas particles moving around. Remember that gas particles move about randomly. So they're just bouncing around all over the place. So for example, if we put all of our gas molecules, let's say we have some gas molecules of xenon, and then some gas molecules of helium. We'll put them both on the left side. And then we can ask ourselves, which one of these are going to effuse faster? And if we think about it, they're all moving about randomly, so they have the same kind of chance to hit this hole. However, our helium is a much lighter gas, so if they're at the same temperature, which they would be if they're in the same container, the helium is moving around much faster, so it's going to have more collisions with the walls and a higher chance to hit that little hole, right? So the helium will effuse faster, and that's because it moves faster. So that's pretty much the only concept that I'd like you to know. If you take a look in your textbook, you can kind of work this out mathematically through Graham's law of effusion, which states that the rate of effusion of A over the rate of effusion of B is equal to the square root of the molar masses divided by one another. Note that kind of they're opposite sides, right? So the rate of A is on the numerator on the left side, and then the molar mass of A is on the denominator on the right side. So again, a lighter gas will effuse faster just because it goes, because it moves faster. This also explains why helium balloons deflate so quickly, right? If you buy a helium balloon from a store, it'll deflate pretty quickly, but if you blow up a balloon with just your breath, it'll stay pretty inflated much longer, and that's because helium is much smaller, so it diffuses faster. You can also take a look at the PhET simulation. The ideal gas law also has some diffusion stuff, so you can play around with that. It's pretty cool, and I definitely encourage you to take a look at it.